and welcome to this week's salon. I'm Adam Smith, and it's great to be back, having been away for a couple of weeks, to host today's session, talking on a topic which I think is probably one of the most important topics we've discussed in the salon because it impacts everyone, and that's green labs and sustainable research. In this session, we're going to ask the question, how can we improve the environmental impact of research without compromising scientific progress? As researchers, we generate incredible innovations, but that does come at a cost: energy consumption, waste, and resource use. And today we're going to explore how we can transform our labs and our research, not just those of you who are based in labs, into models of sustainability, discussing actionable steps, pioneering ideas, and collective responsibility we hold for shaping the future of science in a more sustainable way. And to talk to this topic, we have Andrew Arnott and Dr. Ariana Gatt, who are both hiding. Hi, both of you. You can turn your cameras on. Andrew is a Climate and Diversity and Sustainability Manager at the University of Edinburgh, and he coordinates projects across the university's Sustainable Laboratories program, working since 2015 to make labs more sustainable by increasing energy efficiency, reducing waste, and improving the design of lab buildings. He now works on strategies, policies, and large-scale practices to decarbonise the university and have a positive impact on biodiversity and ecosystems locally and globally. And joining Andrew, we have our own from UCL, Dr. Ariana Gatt, who is a Senior Research Fellow at University College London. And Ariana works closely with the Queen Square Brain Bank, looking at RNA binding proteins in dementia brain tissue. And she's also involved with the university's work on implementing their laboratory efficiency assessment framework, which is called LEAF, which the university is particularly proud of. As many of you know, the format for these sessions is quite simple. Andrew and Ariana are each going to give a short presentation for about 10 minutes. And then I'm going to ask some questions, and we'll invite you to also ask your questions. And then if we have time and enough people here, what we're going to do is we'll join you in the chat so you can share your own experiences on this topic as well. And you can ask some questions if you didn't do that already. But that's enough from me. Andrew has very kindly agreed to talk first. So thank you very much again for joining, Andrew. Do you want to share your screen, and I'll hand over to you?
Sure, let's try this.
I can see that. You're ready to go.
All right, well, thanks for the introduction, Adam, yeah, glad to hear the themes and the topics that lines up well with my work and what I've been doing. So if people on the call have attended lab sustainability presentations before, they might be expecting me to start with ultra low temperature freezers or fume cupboards or maybe benchtop equipment. Now, the impacts from all of those mostly relate to energy, and you as researchers have some control over that, and I will come to those topics as they're still important towards the end. But in my opinion, you can have a far greater impact in the area of resource usage. Every item which comes into your lab has been made from materials which are extracted, maybe grown, but probably mined from the earth, transported to a factory where energy was used to refine and develop the product, perhaps transported to another location for assembly, another for packaging, transported via a complex series of stages in the supply chain to a supplier to your institution, who then delivers it to you. You use it, perhaps for a matter of only minutes in some cases, and dispose of it, where it then makes its way through the waste and recycling streams involving more treatment and transport before finally reaching its end destination. Every stage of that process involves inputs of energy, which currently in many places in the world involve having a byproduct of greenhouse gas emissions from the burning of fossil fuels in vehicles, mining equipment, factories, or power stations. So I hope this illustrates to you why your usage of materials matters a great deal. What I'm showing now is a slide from a pilot project which some colleagues of mine at the Roslin Institute in our vet school did. So sort of to work on to what can we do about it. So there are general principles in relation to waste and recycling labs. and reducing the use of single-use items to a minimum is one of the parts which is the absolute cornerstone and base of the hierarchy pyramid. The lab in Roslin, where I'm showing this slide at the moment, and they have a write-up in a paper in microbiology. They looked at their use of single-use items and critiqued it and said, well, okay, this is officially a single-use item, or culturally we have thought of it as a single-use item, but can we just decontaminate it and use it again? And so they attempted that with a bunch of different things and found that many items could effectively be decontaminated for their usage and managed to massively reduce their purchasing, saving them money, reduce the waste that they were producing, saving the university money, as well as this, their pivot away from single-use items has given them a greater, or reduced their vulnerability, you might say, to supply chain shocks. Now, we may remember them from COVID. There were times when even getting gloves for labs was problematic. I don't think those supply chain shocks are gone forever, and I think it's a side benefit in addition to the sustainability aspects that is quite useful for the robustness and resilience of your lab operations. In 2019, University of Edinburgh employed an excellent intern who actually later became staff to produce a guidance document on lab plastics. So if you're interested, you can search on our website for it, or I can provide a link afterwards. But yeah, it sort of gives options of what you can do, what works, and what has been found to be effective. There are, of course, ways that you can reduce your environmental impact from your use of items and materials by discussing things with your suppliers. Many suppliers offer things which, if you don't ask, you don't get. There are a lot of scenarios where we end up finding out that, oh, yeah, that's a service we can offer, don't worry about it, when we always thought it was not available. So there are take-back schemes for packaging. You can ask some suppliers for reduced packaging, especially in relation to polystyrene. You can ask for recyclable packaging. Even in cold chains, there are some suppliers will use compressed cardboard or other biological materials instead of polystyrene. And yeah, some suppliers offer recycling schemes for used products. So speak to your suppliers and see what you can get from them. Here's the thing which I put up in our internal sustainable lab training, and it may be of relevance for your universities as well, or your institutions. Waste from a lab is not lab waste. And the semantics of that are, a lot of people consider, or are told to consider by H&S or lab managers, anything that has been inside the room that hosts your laboratory is therefore contaminated. And that is factually inaccurate in many, many cases. And it only requires a little pivot of thinking, a little pivot of practices to transition away from throwing everything into some kind of contaminated waste stream to actually thinking about, what is in my hand? Is this contaminated, or can it go into the non-contaminated waste streams? The benefit of that in terms of sustainability is that the non-contaminated waste streams go through far less intensive, energy-intensive and cost-intensive processing. The co-benefit in the University of Edinburgh and possibly in other institutions is, for your lab, laboratories in the University of Edinburgh are charged for their contaminated waste streams, their hazardous waste streams, whereas non-contaminated general waste streams across the university are covered by everyone's costs by our estates department. And so, yeah, your lab can make more effective use of your grants and funding if you're not spending unnecessary amounts on contaminated waste streams. The other side of that is proper segregation of waste. Now, I'm telling you something that you will have been told the first day you walked into a lab, probably something you were told in your undergrad when you went to teaching labs. I apologize, but I'm saying it because it's super important. If waste streams get mixed, so if a contaminated item goes into a non-contaminated stream, everything in that bag, that big bag of non-contaminated waste with one contaminated item in it, is then either going to be spotted, and that whole bag then needs to go for contaminated treatment unnecessarily for most of it, or it's not going to be spotted, and that poses a risk to whoever is working with that waste further down the line. So yeah, some good reasons for paying attention to waste. Moving on to other materials that are in your lab, so more specifically chemicals, reagents, etc. These often come with fairly high embodied carbon, sometimes with fairly high costs. So the sharing of chemicals is super important when it comes to reducing costs and reducing carbon. Scientists that I've spoken to, people that I've worked with in labs, are always cautious about contamination. They don't want to borrow something that's open from someone else, on the assumption that they must be the only person in the whole of the university that is actually following good practice in relation to not contaminating materials. Given that everybody thinks that, sounds like everybody's doing good practice, so I think we're probably fine to share. The other area of this, and it leads on to a slide I'm going to show you later about the 12 principles of green chemistry, is reducing the volume and reducing hazard. I hope my next slide is green chemistry because that would work really nicely. It is. Oh, great. 12 principles of green chemistry. Far too much for me to go into today. I would really strongly encourage you to look it up and investigate it and see if there's anything in your design of your experimental practices that you can change in relation to these. So are you using more heat energy than you need? Could you change that for a catalyst? Are you using more volume than you need? Could you reduce volume and still achieve the same results? Many other things to think about, many of which are far too technically and academically complicated for me. I'm purely a sustainability person, but I find this whole approach really inspiring and really rather interesting. Another area is trying to make sure that the stuff that you do bring into your lab doesn't end up as unidentified waste stream. So if the labels perish, then an item that's in that container, we don't know what it is, we have to assume that it's super hazardous and treat it as such. So yeah, good labeling with high quality labels and pens is good practice for everyone involved in the lab, and also improves sustainability. Okay, as promised, let's get on to the energy side of things. Now, the reason I have pivoted my slide pack and put the energy stuff at the end instead of the beginning is I didn't used to do this. The energy stuff used to be way high up at the front, and that was because the UK's electricity grid used to be very high carbon. It is dropping like a stone. The carbon intensity of electricity is massively reduced thanks to the increase in renewables as a share of our grid. Some of you may be aware that the UK's last coal-fired power station closed last October, I think. So while there is still some carbon associated with electricity usage, and while there is definitely a cost associated with electricity usage, the carbon is reducing. And so I have lowered its priority, but it is still of value and of interest. One aspect of electricity usage which does have a could have a surprisingly large sustainability impact is where you are operating where the local electricity grid is constrained, i.e. there's not enough electricity for everyone that wants to use it, or there's it's very close to that. Under those circumstances, you will have a sustainability benefit by reducing your electricity usage, in addition to the 200 grams of CO2 per kilowatt hour. But anyway, some of you, or many of you, may have already heard about sustainability aspects of ultra-low temperature freezers, and they have a fairly high running cost. They use similar amount of energy to the average household in the UK, just on their own, and that's when they're operating at -80. If you reduce or increase rather the temperature to -70, their energy consumption drops by about 25%. Many materials can be safely stored at -70. In fact, for a long time, ultra-low temperature freezers couldn't go lower than -70, and it's only because the technology has improved that -80 is kind of in the minds of us as lab users. It's not necessarily beneficial. Some people will say, but if my freezer fails, if it's colder to start with, I've got longer before things start to get affected by that warming up. Yeah, so put a monitor on it and put an alarm on it, and still save yourself the 25% energy. The other area to look at in terms of ultra-low temperature freezers is your do you regularly have to search for space? Do you occasionally go, you know what, it's now time to get a new freezer because we just need more storage space? Can you critique your storage of materials and actually go, you know what, that item, it's been in there for 15 years, it has probably degraded even though it's been at -80. We cannot replicate any experimental procedures with it because it's degraded. Why are we keeping it? I understand that there are some protocols which require you to keep things for a certain length of time. I don't think any of them are 15 years. So yeah, critique, throw out, minimize the volume of what you're storing. Try not to store, half a cow's leg when you only need a couple of grams of tissue. Defrosting and cleaning as well also massively improves the efficiency of how your freezer's mechanics work. I'm not going to go into detail just now, but just suffice to say, doing these on a fairly regular basis, the regularity, the frequency should be influenced by the problem. So if you're in a dusty environment, then clean the filters more frequently. Just get a vacuum cleaner out and vacuum the filters. If you're in a humid environment and you're getting ice build up because you've got a lot of traffic going into that freezer, a lot of door openings, then you're going to get more ice, so do more defrost more regularly. But the timing's up to you. I would say at least once a year, but potentially more frequently. Fume cupboards use double the amount of energy of an ultra-low temperature freezer. The way they do this is not so much through their fan speed, it's mostly because they take lovely warm air from inside the lab and they spit it out into the outside, and then that needs to be replaced by cold air coming in from the outside and having to be heated before it's put into the lab or to the building. So it's mostly a cost on your heating. That has a high carbon impact at the moment because almost all heating across universities is gas, and other academic institutions as well. So that we can't rely on more wind farms and renewable energy saving us from the problems around fume cupboards. Fume cupboards currently have quite a high carbon impact, so definitely worth paying attention to. So how do you reduce your impact from fume cupboards? Well, if they have variable air volume control in the plant room, whether you know about that or not is slightly irrelevant. Shutting the sash reduces the airflow, reduces the amount of air that's sucked out of the building and having to be replaced. If they don't have variable air volume, if they have constant air volume in the plant room, then shutting the sash just keeps you safer, and it's a good thing to do anyway. Switch them off when not in use. Lots of people think they can't do this or are not allowed to do this. You almost certainly are. If your reason for not switching it off when it's not in use is because you're actually using it as a storage device and not as an experimental location, please don't do that. It's incredibly wasteful. There are things you can buy ventilated cupboards with ducting, if you need them, ducting to the outside with a small fan which extracts the fumes. And that is adequate for storing smelly or volatile materials, dangerous materials. Those ventilated storage devices, ventilated storage cupboards, are what you need to be using for storage. Fume cupboards should only be used for experiments and therefore should be switched on when not in use. The energy difference and therefore the cost difference and the carbon difference between a fume cupboard and a ventilated storage device is about 90%. The ventilated storage device uses maybe 10% of the energy of a fume cupboard. Helping your fume cupboard to operate more effectively, reducing clutter, making sure there's nothing in the first 15 centimeters next to the sash is good as well. And then face velocity. So this is how fast the air is being sucked through. This is often set at 0.5 meters per second as a default by your Estates Department. That's not based on safety, that's based on a rule of thumb. It may be that it's safe to operate it at 0.3 meters per second, and that will save you 40% energy. It may be that it's not safe at 0.5 and you need to run it at 0.6. So I would strongly recommend you to dig your heels in and ask for a proper containment test whenever face velocity is being discussed or checked on your fume cupboards. Your fume cupboards should be checked once a year by your Estates Department. But one thing which can happen is the Estates person who comes around is being asked to check, is the face velocity today the same as or higher than the set velocity that we wanted it to be at? So if the Estates person comes in and finds that the base velocity is at 0.6 and it was originally at 0.5, they're going to give it a tick, go, yeah, that's fine. If they come in and say, find it's at 0.8 and it was originally at 0.5, they're going to give it a tick. This is problematic from an energy point of view, but it's also problematic from a containment point of view. When phase velocities get high, about 0.7, 0.8, 0.9, they generate turbulence, which can bring contaminants back towards the user. So faster is not safer, and it uses a lot more energy. Okay, I'm just going to rattle through this because I'm using far too much time, and I want everyone to hear Ariana as well. But scientific benchtop equipment, basic rules of sustainability. 1, do you need to buy anything new? Maybe not, maybe you can borrow, maybe you can share. Sharing actually often leads to good collaboration and interesting discussions. Switch it off when it's not in use. Here's a color-coded screen of different common benchtop equipment. The ones in red use higher amounts. These are the ones to focus on. Maybe you can put timers on these if they have regular hours of use so that they're not operating when not needed. Cleaning and sterilization. I'm not sure if anyone on the call has responsibility for this, but there's a lot of energy and water used within this. Drying ovens in particular can use a lot, as well as, of course, autoclaves. Some glass washers come with drying cycles that they're not very good. It's much more efficient to use a glass washer for washing and then a drying oven for drying. Water, I'm going to skip through most of this, but the main things are you've got different levels of energy which go into purifying your water. Try and avoid distilled water. It's very, very high energy. And very often your experiments can operate with different forms of purified water. And the other thing is, if you're rinsing items, some people rinse them by sticking them under a running tap and then walk away and do something else for 10 minutes and come back, and it's been under a running tap for 10 minutes. That is actually not even as clean as if you fill and spill it 3 times and uses a lot more water. Okay, so study design, and maybe Ariana can speak a lot more informed about this, but this is not my expertise. I've never been a lab academic, but here are some thoughts. So try and consider how much travel is required or will be required from your study design, both participants and the researchers. Can the numbers or the distances be reduced? Can mode of travel be changed from high carbon modes to active travel or low carbon modes? Think about the principles of green chemistry I mentioned earlier. Think about replicability. and sharing of null results. And both of these are so that we don't have duplication of effort and duplication of the embodied carbon in that research to do something which somebody's already done. Make sure that as much as possible things are not being unnecessarily duplicated. Okay, I rattled through some of that. There is a lot to cover, but I'll pause now and pass on.
Thank you, Andrew. That was really comprehensive. And that point you made right at the start, actually, I hadn't really considered that a lot of your focus before was on reducing energy consumption, which is what we all kind of think about, right? I mean, we do that in our own homes now as well. But I suppose this is particularly relevant in the UK, where we generate less carbon to produce that energy. But that wouldn't necessarily be the case, I guess, for those who might be watching who are elsewhere in the world.
Exactly, yeah. It's UK specific. If somebody's coming in from Norway or Iceland, they have really low electricity carbon. Someone's coming in from Poland, India, China, they've got pretty high carbon in their electricity. So what the thing where my concern is reducing is electricity. So trying to separate our understanding of energy into electricity and heat as separate things. And where that heat is produced, it's often produced by fossil fuels. Electricity in some locations is produced with renewables. And that's where you can start to reduce your concern and reduce your focus, is when the electricity starts to be produced more by renewables.
And so much of what you said as well seems like kind of common sense if you just put a bit of thought into it. It's not, it's that kind of thoughtlessness that you can see that a frosted up fridge or the packaging you're getting or buying a new piece of kit when there's that same just for convenience, that all of that makes sense if you just think about it a little bit more. It's being a bit more mindful in your day-to-day practice.
Yeah, I'd say that's right. It's not rocket fuel, not rocket science. It's just being thoughtful.
And I'm going to ask this question. It didn't come up because, of course, not everybody who watches this will necessarily be lab-based. Does the university also, I mean, I know you can only speak for Edinburgh, but you connect with colleagues, I'm guessing, from other universities. Does this same work extend across the university for those that might be working in qualitative research, for example, or other parts, not just in the labs?
Yeah, it does much more so now than it has previously. But the approach to the environmental impacts of qualitative non-lab-based research has for a long time been considered that it's wrapped into general sustainability campaigns. So your waste, your switch off, your consider your transport things, which are your generic campaigns across the university. The reason the lab sustainability program started up in 2012, 2013 was that there was an increased awareness that generic campaigns didn't answer all of the really quite specific and technical questions that come in labs. But yeah, the non-lab based research certainly also has a major role to play in this, especially potentially around transport and transport which is impacted or caused by their research activity.
Well, that brings up a good topic about conferences. I know at UCL they implemented a policy, I'm going to say 2 years ago now, that said that if you can get there via Eurostar, you have to. You're not allowed to fly anymore. But there are still so many international conferences that I'm guessing that your lab might almost generate the same amount of carbon for the amount of conferences that people attend flying all over the world, particularly in academia.
It'll depend on your research area, but for sure your travel, it will be a big part of your footprint.
So is there a view on how to address that? Where do we stand on offsetting these days, or not? I know I wrote a piece on this because I was trying to argue that it was better than doing nothing, but yeah. I'm not sure that people buy into that anymore.
I mean, it's better than doing nothing unless it enables the poor behavior to continue, which is like, that's the psychology side of things. There's good offsetting and there's less good offsetting. What you're looking for in offsetting is genuine additionality and longevity. Those things require quite a lot of checking and investigation. If you're buying a flight off EasyJet and it says tick here to pay £1.50 to offset your emissions, probably it's not going to do anything at all. So yeah, if it's suspiciously cheap, don't do it. You'll have a much greater impact by changing your behaviour than by offsetting. If after changing your behaviour and reducing as far as possible, you then engage in a genuine, high quality, big impact offsetting scheme, that probably is better than nothing. But offsetting shouldn't be used to legitimise the behaviour that we're trying to reduce. It should be used for the last 5% that you can't get rid of.
I wonder, I hadn't really thought about this until just now, about we know how so much behaviour change in research is driven by funders. Whether in our particular area in dementia, for example, or Alzheimer's research, a lot of the push to have patient and public involvement, for example, was driven by funders saying, we'll only fund you if you've done co-production or patient and public involvement. About how funders could do this and whether they're willing to accept that there's a tariff you can add on to say, right, in this grant, I'm now gonna, right, this is how much we need, but actually we could add another 5% on to adopt green practices, and whether funders could push back and say, we expect you to adopt best green practice, particularly in animal research, because I'm guessing animal research must generate quite a lot, right? I mean, breeding and keeping lots and lots of mice for a long period of time is, I don't know. Is that a large course of carbon?
I'm sorry, Ariana, I'm dominating here. I don't know if you want to come in. Okay.
No, go ahead.
Two things there. Funders, Wellcome Trust, I think, do specifically advise grant recipients to include offsetting costs in their applications now. Other funders may follow suit in a similar vein. It can get complicated. Sometimes the funder might say, we expect you to use this offsetting scheme as opposed to choosing your own. University of Edinburgh, by contrast, we have bought land and entered into partnership with other landowners to increase afforestation and to repair damaged peatlands in Scotland. We probably wouldn't ever use the word offsetting, but to compensate for unavoidable emissions as part of our operations. And the other area you asked there was about animal research. Animal research does have some pretty substantial impacts, but it's actually getting a lot better. So the impacts are because typically they have to have very high air changes in the room in order to keep both the humans and the animals safe and comfortable. And they've got very narrow tolerances in what temperatures and what humidity is appropriate. Over recent years, lots of animal facilities have shifted to using individually ventilated cages. So instead of the whole room being at a safe condition for the animals, the cages at a nice condition for the animals, and the room can then be allowed to fluctuate a lot more in temperature and humidity. It also keeps the technicians a lot safer because there's fewer allergens floating around in the air, because the cage itself is what's ventilated. And that can reduce the need to produce steam, which a lot of older animal facilities, they've got a steam generator for the humidity, and that's very, very inefficient and high energy. So yeah, it's an area which has historically been very high impact, but over, with technology and also with decarbonisation of the grid should drop.
That makes complete sense. And I know UCL, we're encouraged to contribute to Trees for Life, which is reforestation of some part of Scotland, which sounds like the similar.
Yeah, I know the guy from Trees for Life, actually.
Exactly. Yeah, so I, certainly every time I go away, I do some more trees for Trees for Life. I quite like the idea that even if it's not offsetting, that they're reforesting a place
Yeah.
which also helps wildlife and nature and everything else. And I think we
Yeah.
could all.
That's pretty high quality, the trees for life stuff.
Good. So UCL researchers, Trees for Life, treesforlife.org.uk. And if you look, UCL has its own section in there. Thank you very much, Andrew. Let's hear from Ariana now. Hi, Ariana. I'm guessing you, neuropathology, you lose a lot of fridges, right?
Freezers.
Freezers, keeping your sample.
Freezers, lots of ULT freezers, which I'm going to as well discuss in my 10-minute presentation.
Over to you.
I'm obviously not going to give such a comprehensive view of the sort of system that's in place as Andrew has, but I can sort of give some tools and tips and tricks that we've sort of implemented in our day-to-day life as lab researchers in my lab at UCL. So I'll share my screen. There we go. I think you should all be seeing my screen. So hello, everyone. I am Ariana Gatt, and as Adam said, I'm a research fellow at the Institute of Neurology at University College London. I am a molecular biologist, and I work a lot with post-mortem human brain tissue. I mainly deal with RNA within human tissue, and so I have to work in very sterile conditions and utilize a lot of single-use plastic and sterilization techniques in my everyday work. Also, because I work with human tissue, I have to work at higher biosafety levels. So in my lab, we wear a lot of personal protection when handling the tissue, and therefore, from a sustainable point of view, we also use a lot of single-use plastics in our protective wear. We must change gloves a lot to avoid contamination. We use a lot of disposable scalpels. Fume hoods, which as Andrew showed, use up a lot of energy. We use cryostats, which are obviously constantly kept at a cold, constant temperature and are not really ever switched off. And working with human tissue and in close association with the brain bank here, we hold the tissue bank with frozen tissue, which is stored in these highly energy-consuming -80 freezers. Also, because for safety reasons, we always must assume that all tissue is infected, we must autoclave and inactivate any waste material which has come into contact with human tissue prior to incineration. Because of all of this, I have become quite aware and passionate about truly how much energy and resources are wasted in labs in the past few years. So a couple of years ago, I joined LEAF at UCL. LEAF is a UCL-implemented laboratory efficiency assessment framework, which is designed for a wet lab research environment. Each UCL department is encouraged to fill in a LEAF application once a year, where you fill in each section corresponding to award criteria that broadly cover things like waste, people, equipment, water, and sample and chemical management. This is a great practice and a great initiative because it basically offers a simple checklist for all lab users to go through and look at their general day-to-day impact and how they can improve their practice. The criteria can cover basics like something that also Andrew alluded to, are the bins appropriately signed and labeled so that the appropriate material gets binned in an appropriate and safe way? To, are you training your newcomer lab members in the green practices of the lab? To, how do you deal with resource and reagent sharing in your building? So the LEAF application has 3 levels of award, bronze, silver, and gold. And each passing year, the department is encouraged to implement the criteria for the next higher level and go for that. So a department that has won bronze this year is encouraged to implement silver criteria and therefore go for the silver award the next year. And I do believe that other universities now implementing the system have managed to all implement higher grade criteria and are now mostly working on the gold standard levels, which I believe goes to show that when it comes to actions at the everyday, day in the work life level, I think awareness and training are key. LEAF is a great checkpoint for every lab. However, we all know individuals within a team might like working in a specific manner. There are scientists who don't really like sharing their specific reagents. And also specific labs have specific working environments. I think one of the main issues within the UK and I think Andrew would agree with me, is that some UK-based universities are in buildings where the labs are based in buildings that are really quite very old. They are not necessarily built for purpose for a scientific laboratory in 2025. They have old plumbing and electrical systems, may not be the best ventilated or temperature controlled, which then lead to high-tech equipment such as ULT freezers, maybe being even more energy inefficient purely because of the room in which they are in. Newer buildings now being built are obviously, and rightly so, taking energy efficiency and green practices in mind, and speaking to people like Andrew, who are experts on the matter when designing lab space, but some teams will still be working in the older spaces. And so we'll have to do that little bit of extra and be a bit more mindful when it comes to their everyday practices pertaining specifically to their team. For example, we have now implemented a cleaning rota in our lab, whereby every 2 weeks, 2 rotating members of the team prepare stocks of common buffer, check common antibodies and reagents, check out-of-date material, and then importantly, update the databases, checking that the waste has also been disposed of in the appropriate ways, all solvent is ready for collection, for pickup, and so on and so forth. I think organization in a lab environment is key. I have worked in multiple labs and find that, like kitchens with multiple chefs, unless routinely cleaned and kept an inventory of, there will be things getting lost, getting out of date, frustration, waste, and space being used up erroneously. Recently, we have reorganized our lab research freezer at minus 70 degrees. I'm really proud of this picture. We reorganized the space purely by rethinking how we can keep our material in the freezer. And we needed to do this because when, like us, you work with huge amounts of samples and tissue that need to be kept at ultra low temperatures, you need to make sure that it's organized in a way where not only everything is safe and kept at the temperature it needs to be, but you also minimize the time that the freezer is open. This is because of energy efficiency, but also because every time you leave the freezer open for too long, you are risking thawing out some material where you might lose its scientific integrity. And so we reorganized the space and moved most of our samples purely just from bigger bags or tubes to smaller spaces. We collated them into organized boxes, which we now have a database for. And this alone has won us the space of the whole freezer. And it also saves energy day to day because, as I said, the freezer now has to be opened for a much shorter time on average in order to find the sample that you're looking for. Similarly, we implemented a recycling section in our lab. So we, like many other labs, get a lot of deliveries from suppliers with cooling bags and excess cardboard. And these can always be reused when shipping samples yourself, obviously, if it is deemed safe to do so. Or similarly, you can use for storage within the lab itself. We are also part of a WhatsApp group within our building at UCL, where we constantly discuss any building issues and who has filled in a report to estates. But we also use it to share resources, discuss deliveries of, for example, dry ice, share any excess dry ice, for example, that a lab might not need anymore on a day, rather than letting it go to waste. Additionally, we're all part of a scheme whereby empty pipette dip boxes get picked up and resent to our supplier for reuse. I think a huge step forward we have taken recently as a building is something that, again, Andrew spoke about, is switching ULT freezers from minus 80 to minus 70 degrees. This can save up to 30% of energy, also extending the lifespan of the freezer itself because it needs to work much less harder to maintain the temperature at minus 80 than if it's keeping it at minus 70. And enough studies have been done now to show that biological samples, even RNA itself, which I work on, can remain stable and integral at minus 70 degrees. So I do believe that things are slowly but surely moving in the right direction. and schemes like LEAF have really had an impact in this. I think there are actions that can be taken at the individual or at the team level, and that is obviously more of what I feel comfortable discussing with my team and my peers and fellow lab researchers. Then there are obviously actions that can and should be taken at the institutional and systemic level. Even the funders, so as Adam just alluded to, and it's a thought I've had myself as well, should grant applications include a question regarding sustainability of your project? Something again we just spoke about, UCL and I believe many other universities have recently implemented the travel clause, whereby scientists looking to travel away for conferences, which is something we do a lot, which can be overseas or local, must travel by train if geographically possible. Similarly, something I learned about recently is the Sustainability Initiative launched in 2020 by the Company of Biologists. This actually includes grants available for conference attendance to become greener. So by topping up travel costs, but ensuring a more sustainable option. So getting a train to Edinburgh sometimes is way more expensive than getting a flight, but if you could apply for a grant that covers the excessive cost, then that would make that attendance way more sustainable. So I also will conclude by saying that suppliers and funders also have a huge role to play in ensuring sustainable practice as we move forward with research. I think suppliers need to be held accountable for not having recycling schemes, sending materials separately rather than combined, with excessive packaging and with excessive cooling material. There needs to be greater transparency in the supply lifetime chain of a product. Again, something that Andrew discussed. We might buy gloves that are more eco-friendly, but how many are there per box? Where are they being produced? What kind of waste do they produce when incinerated? The box they come in might be cardboard and have less shiny plastic, but as a whole product, is it truly more environmentally friendly? And I will conclude by saying that maybe it is too much to expect that a PhD or a postdoc in the lab has also the time to look into all of this and research all of this. And this is why having sustainability teams within unis with catch-up meetings is so helpful, because the labs can individually then get updated as to how best to implement better and greener practices in our everyday lab life. That was my thoughts on the matter.
Thanks, Ariana, and well done for taking on that role in your team as well. I love your fridge, by the way. Is that I'm guessing that wasn't your kitchen, but
No, we were so proud of that.
the fridge is beautiful.
It is a -70 freezer. It was obviously, it looked very defrosted because we had just paid quite a bit of money actually for the new racking system of the freezer. But even that in itself made such a huge difference, honestly. We actually combined 2 freezers in one, just by having a more organized freezer. And yeah, we now have a system in place where everything is numbered and we know where everything is. Everything fits 4 boxes exactly. The boxes are numbered, and it's great because it does happen that you end up with multiple homogenates of the same bit of tissue because people have done it for different projects. People over the years have done it for different projects, whereas now we have it all combined, and that doesn't happen anymore.
How long did that take you? Is this your way of procrastinating? Was that?
That's my way of organizing. No, so we all thought we needed it, and thankfully we have a a mentor who supports our ideas, and she said, yes, I think we should get the money for a better racking system, and it's made a huge difference.
And you mentioned there at the end about PhD, not expecting PhD students to necessarily pick up on this. Are there some obvious things? I guess I'll put this question to both of you, that you think the most common unsustainable practices that people could change What did you see, Ariana, when you started? When you walk around the labs at UCL, what do you see as the common thing that people could change?
Well, I think it does require a conversation because, as I'm sure Andrew is aware of, sometimes the more sustainable choice is not the cheapest choice. And the truth is, we don't have unlimited amounts of money. We do research where we buy really expensive antibodies. We use a lot of money for animal practices. So then maybe some people are more inclined to, like, well, I'm going to buy the cheaper gloves and the cheaper falcon tubes and the cheaper, sample tubes because that's where you can save a bit of money. And so I can see how even say a PhD student or a postdoc, they're not going to be that person to say, yes, I know that this costs 3 times as much, but it saves 50% of plastic. And sometimes I have myself bought kits that were a bit more expensive because I said I will make that choice, but they were claimed to be the more environmentally friendly and the greener kit for RNA extraction, for example. So I bought that only to find out that when it came, it had half the reagents missing that I had to then get from elsewhere. And that's why obviously it used up less plastic or less, was more environmentally friendly. And so what I mean is we don't necessarily have the knowledge to always make an informed choice, nor the time or the financial responsibility, because that doesn't fall within our realm, unfortunately.
And I guess this is where, Andrew, universities, I'm assuming, work with their procurement departments to kind of lean on suppliers to, particularly packaging. I've seen some horrendous social media posts with the amount of packaging that can come for tiny little things, which must be frustrating.
Yeah, absolutely. I mean, an institution as large as University of Edinburgh and UCL and the equivalents around the country and globally, I do feel for our procurement teams. They will write into tenders that the winning contractor must do X, Y, and Z, but policing that on the ground is a lot more difficult, and it can be that the tender says that the supplier is going to do wonderful things, but if we don't then hold them to it, they forget. But yeah, it's an area where open communication and good levels of support between the centre and the labs is important. And I mean, any management consultancy piece that has ever been done on universities will say communication. Like,
well, that's it. It's doing something about it.
Every problem.
And I guess for you, Ariana, when you've got to write grants, you've got your limited budget. When is it obvious to you when you go to order these things, kind of which is the better? Is that clear to you all the time?
No, it's not. I think a trick is asking questions, as in, for example, yes, there are these schemes, particular, for example, supplier chain that are quite good at collecting empty pipette tip boxes, for example, and reusing them. And they have sent a sustainability expert from within their team to speak to us at UCL, and I met him, and we actually went around the lab, and he spoke to me about gloves, and he spoke to me about the different kinds of plastics one finds in tip boxes and gloves, and how you can only recycle one specific type of tip box, because if, like Andrew talked about the contaminated waste previously, if you have a tip box that is made from a particularly different type of plastic within the same other kinds of tip boxes, that will really mess up the recycling process of all those tip boxes. So it's these little things that we're not aware of. But what we can be aware of is, for example, okay, I've set myself up with this scheme where my tip boxes will get recycled. Where will they be collected from? Will they come to my building? Will they go to a different UCL building on another day, thereby actually really not being sustainable at all? can we walk over to a building and take them, say, every Friday afternoon, and therefore they just come do one pickup rather than 5 different ones? It's these little things where you need to find the people within other teams or within your department that are responsible and actually have the answers. Where does the solvent waste go? If I am sending my tip boxes back to a supplier, but all they're doing them is putting them in a recycling bin outside of their building, then I might as well do that myself. So it's asking the question as much as possible.
One thing, and I will show my massive scientific ignorance here. So some of these problems with recycling and with suppliers, and with the eco product costing more, and with not really being convinced about the eco credentials of different eco products and not having time to investigate it, all of that isn't a problem if you just reuse things, but that requires you to have sufficient decontamination processes. So the lab that did a lot of decontamination in Roslyn was a microbiology lab. I don't know if the type of work that you do, Ariana, or others on this call, it requires such high levels of decontamination that it's not practical. I would say that the decontamination process that they did in Roslyn did involve autoclaving. So they managed to put plastics into an autoclave, get it back out, and use it again. It hadn't like completely melted into a mess. So different types of plastic react differently in the autoclave, as I'm sure you'll have seen many times. So yeah, but I was just hearing all of these problems, and like, these are, if you do have the option to do the decontamination and reuse in-house, it gets rid of all of those problems. But I don't know if you've got those options.
I think there will be that option when it comes to certain things that are done routinely in a lab. When you're talking about RNA practices or anything that touches human tissue, that's not really going to be an option for us, at least. There's biosafety issues, and then there's research integrity issues when it comes to RNA work. You know, I think one of the main issues we have in the lab, and I think it's not just us, is pipette tips. You can run a qPCR plate or a PCR plate and use a whole, if not two, pipette tip boxes. I have to use the filter ones because I do RNA work. Somebody doing a histochemistry and immunohistochemistry stain doesn't need to use filter tips, so we have to make sure they don't, because if they do, that's wasted money, and it's obviously extra waste material. But I do believe that there has to be a compromise, because obviously as researchers, if your PCR plate at the end is contaminated, then that's extra waste because you just have to repeat the whole thing, right? Yeah. So there has to be a balance, but inevitably, surely we do have the conversations of where can we reuse pipette tips, decontaminate rather than throw out. But there are situations in which, at this moment in time, I just cannot find alternatives and carry on doing.
The pipette tip washer available from, I think it's Granova, yeah, which comes in at tens of thousands of pounds, but if you're using a lot of them, it makes sense. And exactly. You have sufficient technician time or somebody's time to stock it, and yeah, so their spiel is interesting, and I haven't checked this out, but they say that the pipette tips come out of their washer cleaner than when you buy them. So when you buy them, they just come out of the mold and they've got a residue on them from the mold, whereas when you put the pipette tip washer, they don't have that. I don't know if that's true or not.
I mean, when doing staining, you can even use, good old glass pipettes and clean them and autoclave them, and that would work just as well. But when it comes to nowadays standards we have for, I think, RNA work, and also when it comes to handling human tissue, there's just...
And I suppose this is where there's a field in itself, isn't there, in researching what is the latest and best and more sustainable ways to perform the research itself. So I guess you're following guidance, Ariana, that
But I think that's a really good point. I think, nowadays universities, like my building, is now convinced to move from -80 to -70 for all the ULT freezers because there has been enough research to show, look, this is fine. This is not going to touch upon the integrity of your research. It would be great if there's more funded studies looking into whether we can reuse material for working on human tissue or RNA or but I think we would need to see that before we implement it ourselves.
You want that research into that.
Yeah, that would be excellent if we can fund more of our interested and inspired and motivated academics if we can allow them to do the thing they want to do, which is find out how to do science with fewer downsides.
Yeah.
Well, we've reached the hour, and this has been a fascinating discussion. I think between Ariana's some awesome practical things that I think hopefully inspire you to go away and think about your everyday practices and what you're doing in the lab, or even if you're a qualitative researcher, about the journeys you're making, the way you work. I know even for us, I mean, essentially we have a website and a podcast, and we even measure the carbon footprint that our website produces and have changed some of the practices we do. So using JPEG images instead of larger PNG images, because JPEGs can get converted to WebP, which makes them smaller. They generate less data, they download less, and it uses less energy. So I know it sounds ridiculous, but websites have carbon footprints too. So we're looking at all this as well, and as I hope you are in your labs. So whether that's small changes to your everyday practice, making sure you're adopting your university's policies, and if you're in a part of the world where this isn't high on the agenda, see if you can do what you can to raise the profile of sustainability in your lab and go talk to people, or talk to Andrew. Do you have I found you through a group. Is there a place people you would recommend people go, or interested in finding out more on this topic? Is there
yeah, there's no, I'm slightly out of date because my role has moved on from labs, but there's the Laboratory Efficiency Action Network, or LEAN. Lean actually birthed Leaf, which was very confusing in conversations for quite a long time. But it's it started as a UK-based network of practitioners. It's actually international now. Use a search engine and find Laboratory Efficiency Action Network, and that is a good active network where people ask questions of each other and find out best practice.
Thank you very much. And of course, I know our UCL's website has all the LEAF stuff on there, as much as it's a UCL thing, or that those same practices can be adopted anyway. Thank you very much to incredible Ariana and Andrew. You've been amazing guests, and we'll look forward to seeing you all in the salon again next Wednesday. Thank you.
Thank you.
Bye-bye.
Bye.